Okay, so today we're going to talk about a skill that's extremely common, especially when you're trying to run an experiment in chemistry. So let's say that you're wanting to run a particular experiment, and the experiment calls for a solution of 1.5 molar, and we'll say that the chemical you need is sodium hydroxide, or NaOH, and you need 500 milliliters of it. So you look at what chemicals you have on stock, and unfortunately the only sodium hydroxide you have is actually at 3M or 3 molar. And so the question is, can you run this experiment still? And actually you can, and it's pretty simple what you'll have to do. You're going to have to do a dilution. So again, the problem is we have 1.5 molar. We need 1.5 molar, but the only chemical bottle we have is 3 molar. So what are we going to do? Well, maybe we could water it down. If we could water this down or make this 3 molar less concentrated, we could actually dilute it or water it down to 1.5. So we're going to dilute. The problem begins, the next problem we're going to encounter is, okay, but how do we do it? How much? What are we going to do? So it seems pretty obvious we're going to have to make the 3 molar less concentrated. We could do that by adding more solvent or more water, but we need to know precisely what needs to be done. So to do that, we're actually going to use a new formula, and this is going to be called our dilution formula. Now, the dilution formula is really simple. It's simply the molarity of solution 1 times the volume of solution 1 is equal to the molarity of solution 2 times the volume of solution 2. So what we might look at here is we can start plugging in numbers to see how this might work. So solution 1, that's going to be the solution we're starting with, the solution that we actually have. So at the beginning we said in our stock room we actually have this 3M or 3 molar sodium hydroxide. So we can fill that in for M1. So M1 is going to be 3. Now, we're not sure how much of this first solution is going to be needed, so instead of putting in an actual number, I'm going to carry this variable here and just keep it as V1. And I'm going to set that equal to chemical 2. Now, chemical 2 is what we're going to try to make, and these two variables we actually know. We need a 1.5 molar solution for chemical 2, and we need it to be 500 milliliters. So, we can start to fill these in. So the molarity, again, we need it to be 1.5, and we're going to need 500 milliliters of this stuff. So this math will actually help us figure out how to prepare the solution. So all we're really going to do is solve for V1. So we'll do a quick calculation here. We'll simplify the right side, 1.5 times 500. So our right side is 750. So right side of the equation, 750. We'll set that equal to 3V1. And then, of course, to get V1, we're just going to divide 750 by 3, 250. So V1 is 250 milliliters. So what does that actually mean? Well, what it means is we're going to take that bottle of the 3 molar and we're going to take 250 milliliters of that chemical from that bottle. Once we have that 250 milliliters, we're then going to add water. We will add water until the solution reaches a total volume of 500. So again, we're watering this down, and we're able to use some mathematics here to figure out the precise amount of the starting chemical we use and how much water we need to add to water it down to get to our final volume. Now, let's look at an actual word problem, what this might look like. So, just got a sort of a baseline kind of question here. I'm going to zoom out a little bit here so we can take a look at this. Okay, so here's a question. How many milliliters of 2.5 molar sodium hydroxide are required to make 525 milliliters of a 0.15 molar sodium hydroxide solution? So again, we are going from something that's more concentrated to something that's less concentrated. We're going to do this problem exactly like we did the example one before. We're going to use the dilution equation. And we're going to pick out our variables. So again, when I see words like to make, that means that whatever I'm making is going to be the M2 and the V2. So sometimes it's useful for me to make a little chart. And just kind of collect the information from the problem. So I'm trying to make a 525 milliliter solution. So if I'm making that, that's going to be V2. So my end goal, I'd like my final solution to be 525 milliliters. What molarity is that solution I'm trying to make at the end? Well, it's 0.150 molar. At the beginning of the problem, what am I working with? Well, I'm working with a 2.5 molar solution. So that's M1. What's V1? Well, V1 is going to be what I'm solving for. So that's a question mark or an X or whatever I want to make, or I could just leave it as the variable V1. So let's just plug in what we got into the formula and see what happens. So what I can do is simply plug in the variables. I'll plug in 2.5 for M1. And I'm actually going to leave V1 as just V1, so I'm not going to make it a question mark or an X or anything like that. I'm just going to leave it as the variable as it is in the formula. And then M2, I can plug that in. And then V2, plug that in. Now, a question that'll normally be asked, and rightfully so, when we talked about molarity, we really stressed that you had to be in liters. So whenever people use this new formula, this dilution formula, they always like to ask, well, do I have to convert volume into liters? And the answer is you do not. Now, you could do that if you'd like to. You could switch this 525 into from milliliters to liters, and you'd have 0.525. And that would just mean that your answer would come out in liters. Now, you've got to be careful because this particular problem asked for milliliters specifically. So if they ask for milliliters, then you need your answer to come out in milliliters. But as long as you're consistent, as long as V1 and V2 are consistent measurements, they're either in milliliters or in liters, it'll be fine. Just realize that if you plug in milliliters for V2, that the formula will spit out milliliters for V1. If you plug in liters for V2, then the formula will spit out liters for V1. So just kind of keep that in mind. So again, we're just kind of looking at some basic algebra here. So we'll go ahead and calculate. So I'm going to simplify the right side. Take the product of those two numbers. And I get 7.875. And then on my left side, I basically have 2.5 V1. So I need to divide both sides by 2.5. So V1 is going to be equal to 7.875 divided by 2.5. And when I do that calculation, I'll finally get my final answer. So 3.15. And again, as I look at the actual calculation, I did put milliliters into the formula, so I know that the volume that comes out of the formula is going to have to be in milliliters. And a lot of times, you just need to make sure, if you're solving for volume, make sure you're solving for the unit of volume that the question asked you for. In this case, they asked for milliliters, and we ended up in milliliters, and that's fine. So again, this is a very common dilution question that you might encounter.